moles be close to. Remember, in the metric system, this is 10. Is moles G smaller or bigger?
Smaller.
So we know it has to be smaller. Is it smaller than half or bigger than half of G?
Smaller.
Smaller. So it has to be less than half of the weight. So it has to be less than 50. If we cheat and do non-collect math, because these are different units, you can say M is a 10. It's some really crazy conversion units. So that means M will still be 10 over here. It's some really crazy units. And we will get something around 42. Okay. Do we have a number close to that on the test? 38. Any questions and then convoluted question?
I have another chapter for it.
Okay?
This one has a drawing on it, so.
Okay. This one?
It's the final maybe 19?
Yes. Spring 19, final exam, question 3. Okay. So, two forces. F1 equals 100 newtons, and F2 equals 20 newtons. F on a 10 kilogram block mass. Theta equals 60 degrees. I'll draw the picture once I'm done writing the question. What is the horizontal acceleration on block coefficient of kinetic friction is mu k equals 0.1. So now there's a picture. We have this mass, 10 kilograms, with F1, theta, F2. Okay. Thank you. So we have a block. Have some mass on the surface. Have one force going like this, another force going like that. Okay. Stat all of the forces acting on it. What else is acting on it? Gravity. There's gravity on this. Is there another force?
Friction.
There will be friction, but there's also you're living there, a normal force.
Oh.
Wherever you're on the surface, gravity's pulling on us. Gravity's pulling on it. The gravity's not pulling on it. Is it floating off to space? Why is it not going down? There's a normal force pushing up against gravity. They cancel. We need to consider both of them. Good.
I see where you're like, there's so many like forces everywhere.
Well, that, the professor, it's like a different like, deviation of what we've been doing. It's like what the really seems as well.
What do we know in this problem?
We know the two forces, and then it's the mass is 10 kgs.
We know, I'm just repeating what you say loud.
Okay.
F1 equals 100 newtons, F2, 20 newtons. Is that agreement with the
Yeah.
problem? Okay. And what else do we know?
Theta 62.
Theta 60.
And the mass of the block is 10 kilograms.
Yes. Mass is 10 kilograms. One more known.
And the
The
kinetic
friction.
Yeah, the coefficient of kinetic friction,
0.1.
0.1. What are we looking for?
The horizontal acceleration.
Acceleration. Okay. So if we want to find acceleration, what do we need to know about the block?
To move the normal force.
We will need to know the normal force. But
The friction.
can you tell me how far can I go this way without being out of shot?
Alright,
Okay.
you're off now.
Thank you. Okay. We will need a normal force. But there's a more fundamental thing we will need to know. We need to know friction, and what do all of these forces become when you add them together?
Horizontal.
Net
Net
force.
force, yeah.
You need to know the net force. This is the process of solving a force diagram. You all need to know net force. F1 plus F2 plus F3 M times A. So in X direction, F net equals. What forces do we have in X?
Force 1 and force
Okay, we do have force 1 and force 2. Is all of force 1 in the X direction?
2. No.
No. This is force 1. That's the X direction. How do we get the X component of force 1? We do some trigonometry. That's physics. Physics 108 is when you are allowed to use trig. Okay, so what trig identity?
Cosine.
Cosine, you can say it with pride. So, the cosine of theta equals F1x over F1. So we get F1x equals F1 times cosine of theta. We need cosine of theta. Okay. So one more force in X, and that is the
Normal force.
not normal. this does not move that easily. Friction. So we also have friction. Okay. So, we go through and plug this in, you will get 100 newtons times the cosine of 60 plus 20. Will it be plus? Minus. Really opposite directions. All of this has to be added to our friction. Now, friction, would that be making us go faster or slow? Slow. So the friction will be, I'm putting the minus sign in red, because whatever this number is, we need to make it small. If this is negative, you'll make it closer to 0 by going up. If it's positive, you'll make it closer to 0 by going down. But what would the equation for friction be?
Coefficient times normal force.
And that is good. What is the equation for normal force?
Mass times gravity.
That is a trap. No, mass times deceleration due to gravity is what you do 80% of the time. Because you have to force the gravity to go down, and you push back up. And we have another force acting on this. Force 1. Is force 1 pushing it down a bit? It's pushing it to the side, but if I have a Fx, what happens to this part? You also have a Fy. Some of this is being pushed down. All the way down. Some of it down, some of it down. All of it horizontal. So the normal force will be equal to force of gravity plus Fy. Force of gravity, that's the mass times g. And force 1y, what would that be?
So F1 sine of 60.
Yes. And Dr. Rosa will have an answer on your test. Will the answer on the test that will agree with what you get if you forgot that part. Because it's not just random numbers for multiple choice. It has to be mistakes you're likely to make. So now, this goes here. We get 100 newtons times the cosine of 60 minus 20 newtons plus friction. We'll calculate friction next. Let's do this part. I might sneeze. Does someone have cosine of 60?
0.5.
0.5. Okay? This becomes 50 minus 20, which becomes
30.
okay. So, will friction be positive or negative? Negative. Friction is always the opposite of your pushing force. If you're pushing this way, friction's the other way. You push the other way, friction is down. That's why I was not going to put a sign for friction in the stall. I was just adding. Okay, minus pressure. M times G. What's our mass? 10 kilograms times acceleration due to gravity, that is, plus force 100 times sine of 60. How much is the sine of 60? 0.87. Okay. So we get Doing newtons minus 100 newtons plus that's what we did. 100 times 0.87 is the mass actually 10?
Yeah.
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 It's 10 kgs.
10 kg. Okay. And F1 was F2 was at 200 in that 20?
Was F2 200?
No, F2 is 20, F1 is 100.
And the mass is 10.
The friction is 0.1.
Okay. Right, we have the coefficient here. Yep. We also need to multiply by UK. Sorry for panicking, you guys. Guess you can drop your tables in full test. 100 times 0.87 is UK. 100 plus 87 is mu k was how much? 0.1. Doing newtons. Okay? So doing newtons minus, what does this become? 18.7 is basically, it's basically 19. Doing minus 19 is, okay, that's F net. What's F net what we were trying to find? Acceleration. So we come back to define the part of the equation. F net equals F1 plus F2 plus F3 plus F times A. We know this part, 11 newtons equals M times A. What is our mass? 10 kilograms times A. What is A? 1.1 units. Yes, meters per second squared.
Yeah.
Yeah. See, and here's the thing, if you guys look up some videos and friction and normal force online, they'll go tell you F normal equals minus F times G. That is a very specific equation. That's only true if nothing is acting on this except for gravity. But here we have a downward force. So the way I will tell you to remember what normal force is the opposite. Negative sign just means opposite in physics of your downward, of your Fy down. All of your forces acting down. Technically, that's not even correct because if I have another force pushing up, that decreases the normal force, but I don't think that will also ask those type of questions. Okay. Well, that is probably everything you can get out of a Newton's Law question. Any questions on that problem? Do you guys want to move on to something new? Okay. What else do you guys got?
I don't know. It's just
Okay. Let me erase.
Oh.
Actually, I can read it out anyways. Number
I want to read.
5?
Yep.
Okay.
The one underneath the one we just did.
Okay. So, number 4.
Yeah, number 4.
Okay. Okay, so this is the same exam, final exam spring 2019, question number 4. This is from chapter 5, which is circular motion. Okay? So, A, 0.6 kilogram and 1.2 kilogram model airplane. Airplane fly in horizontal circles. The speeds all be the same. And same code. The smaller circle has 0.6 kilograms plane fly is radius 3.5 meters. What is smallest radius? Or mass equals 1.2 kilograms plane. So, thank you. Okay. So what we have now, we have 2 airplane toys going in circles like this. The rope is the same for both of them. But the difference is the radius and the mass. Okay. What do we know of this problem?
The radius is 3.5.
Yes. radius 1 is 3.5 meters for which plane?
The small one.
So, so I'm going to write a line here to tell you these two pieces of information go together. Mass 1 equals 0.6. What else do we know?
Mass of the second one is 1.2 kilograms.
Yeah. And we want to find what about that airplane?
The radius. That's what.
We want to find radius. Okay. Both of these are on the same wall. And that actually does tell us something. The same type of wall. That does tell us something important. So before we get into that, what equation do you think we're using if we're spinning something in a circle? Why is this not falling to the ground? Holding it, so I'm applying a force. My force is keeping it in a circular motion, a centripetal force. And what is the equation for centripetal force?
Force equals m times v squared over r.
Centripetal force equals mass times velocity squared over r. Now, since these are both the same wall, I have a piece of wall, I can stretch the wall, but if I stretch it too much, what happens? It snaps. Both of these are the same, so they both have the same snapping point. So that means the maximum force will be the same. Does force go up with bigger or small radiuses? Small. All go smaller. You divide by a small number, you get a bigger force. That means the two forces have to be equal. Okay? So, FC1 equals FC2, which means M1 times V squared over R1 equals M2 V2 squared over R2. What did this problem tell us about the velocities?
The same.
The same. These don't need subscripts. And what does algebra tell you you can do if you have the same thing at both sides? Cancel. And you guys now control a party because this is a much more friendly equation. Using what we know, can we solve?
Yeah.
Yeah. Mass 1 is how much?
0.6.
Oval, radius 1.
2.5.
What's mass 2?
1.6.
Yes. Oval,
Or 1.2.
1.2?
Yeah.
Yes. 1.2 kilograms oval, R2. What would? So these two ratios have to be the same. How do I go from 0.6 to 1.2?
Square.
Times 2. So what do I probably need to divide R2 by? Well, what do I need? What does R2 probably have to be?
7.
7. Why 7?